Welcome you all my lecture series of Principles of Compiler Design. In this video, we are going to see about types of an automata. In the previous video, we know that what is an automata and what are all the basic concept required to implement an automata. So the types of automata, we have we have the three types. One is a finite automata, then Pushdown automata and Turing machine. So the finite automata is again classified as a deterministic finite automata and non-deterministic finite automata. Now we will see what is that major differences between that finite, Pushdown and Turing machine. So the finite automata require no temporary memory. We have a state, we have given an input, we go to the next state. So there is no temporary memory in the finite automata. Next is the Pushdown automata. In the Pushdown automata, we have a stack, that is a temporary memory. It is a stack is used to save the input. Next is a Turing machine. We have the random access memory. So these are all the memory classification in the three types of automata. First we will see what is a finite automata. So the finite automata, we have an input and we have an output. So there is a no temporary memory in the finite automata. So the example of a finite automata is a vending machine. In the vending machine, we are given the input as a coin and finally we get the output as a some product. That is a vending machine example. It is a example for the finite automata. We have a small computing power is required for the finite automata. I told that the finite automata, it is a two different types. One is a deterministic. Deterministic means for a single state, for a single input, we go to the next one state only. But in the non-deterministic, from the single one state, for the given input, we go to the multiple states. That is the difference between the deterministic and non-deterministic. ஒரு ஸ்டேட்டில் இருந்து ஒரு இன்புட் ரீட் பண்ணால் ஒரு ஸ்டேட் இன்னொரு ஸ்டேட்டுக்கு மட்டும்தான் போக முடியும். பட் இந்த non-deterministic, from the single state, when you read the input, we go to the multiple states. So we have to implement easy in the deterministic. So we can easily predict in the what is the next state in the deterministic. But in the non-deterministic, we output is a multiple state, means we cannot implement and we cannot predict the output next state. So it is a very complex compared with the non-deterministic finite automata. We can easy to analyze in the DFA, but it is a very complex to analyze in the NFA. In the NFA, we have the epsilon transition, that is an empty string transition is available in the non-deterministic finite automata, but in the DFA we don't have an epsilon transition. Next is a Pushdown automata. So in the Pushdown automata, we have a temporary memory as a stack. Okay, so the example of a Pushdown automata is the compilers for the programming languages. We have required the medium computing power to implement the Pushdown automata. We have a transition dependency mainly on we have a transition on PDA are defined in terms of a states, input and the stack. So the stack, it contains the push and pop. So the operations of push and pop is to manage the data on the stack. So when you are reading the input, we are going to push. When you are writing, we are deleting, means we are going to pop the corresponding input from the stack. So the transition of PDA depends on the states, input and the stack. Next is the Turing machine. So the Turing machine is required the RAM for implementing the process. So we have an input and output and also we have the memory as a random access memory to store the particular input to output process. So the example is any algorithm is requires highest computing power, means that is we are using that Turing machine. So in the Turing machine, we are the machine reading the symbol and write the symbol, and also it move to the next ticket. We have the head, that head is read the symbol on the tab, read the symbol and write the symbol into the tab, and finally the head is moved to the next symbol. So the transition mainly depends on that based upon the input, states and the head movement. So this is the difference of the Turing machine. So the Turing machine requires the most highest computing power compared with the finite, pushdown and then automata. So these are all the general classification between the finite automata. So the finite automata requires the regular language to recognize the language. So we don't have any temporary memory. The example as an elevator, vending machine, traffic light is an example of the finite automata. Next is the pushdown automata. In the language required to implement the pushdown automata is a context-free language that will be seen in the upcoming videos, and the memory is managed by the stack, and the example implementation is done in the compilers. Though the algorithm requires a medium computing power, we can use the pushdown automata. Next is the Turing machine. The Turing machine, we are using the unrestricted grammar. The language can be implemented in the unrestricted grammar. So the random access memory is used to manage the memory, and with any algorithm requires the highest computing power that uses the Turing machine. I hope you will understand what are all the three types of an automata, how they can difference in terms of a language, memory and the implementation. Thank you.